All right, so we're back with a fingers crossed short short lesson on expected value and how to calculate it. So I've been taught how to create expected values like 7 different ways by 7 different teachers, and the method that I'm going to use today is the one that I think makes the most sense to most kids. And actually, as an adult, when I had someone explain it to me this way, I was like, oh my gosh, yes, like that's so much better. Think of it that way. So the expected value for a random variable in a probability distribution is defined as this, okay? So if you multiply the, hold on, time out. Okay. Sorry, my phone was going off. Okay, so if you multiply the random variable times the probability that that will occur, and then you add up all those different possibilities, let's just say it that way, you're going to create what's called an expected value. So expected value is utilized quite a bit in insurance companies and actuarial science. There we go. Lottery tickets, determining whether you should have a fundraiser or not. There's really quite a few practical applications, and I think this is like fascinating stuff, but I'm a big nerd, so I don't know how you'll feel about it. This example here is about a raffle ticket, and this is, I think, from your textbook. So for the sake of time, I'm just going to skip ahead to the questions. So I am looking at the wrong worksheet. There we go. So this is on our worksheet 8B. It's at the bottom of 8B, and it's kind of attached to our probability distributions lesson, but it's a separate concept, kind of. So that's why I separated the videos. So we have our resort, and we're planning a bicycle race, and the cost of sponsoring the race is $8,000. And then the resort expects to make $15,000 on this event. So we're deciding to change this wording a little bit, because when they say make $15,000, like that's confusing whether it's profit or revenue. So we're going to say that they bring in $15,000. So if you want to do a quick little subtraction there, that means they're looking at a profit of $7,000 if the event actually occurs. So problem is they're in a place where hurricanes are a problem. So there's a 30% chance that there might be a hurricane, and in the case of a hurricane, the race will be canceled, and then it's not going to be rescheduled. So basically they're going to lose this $8,000. So they want to know what's the expected profit, the expected value of having this race. So let's talk about the various outcomes that could occur. So the 2 outcomes that could occur are hurricane versus having the race. So a 30% chance, so let's say 0.3, that you have a hurricane. Well, if you have a hurricane, if I want to think about how much money we're bringing in, well, we're not bringing in any money. In fact, we're losing the $8,000, so we're losing $8,000. But the other outcome is a 70% probability, right? Because if it's not going to have a hurricane, it means we are going to have the race. And then the money that we're bringing in here is, remember, it brings in $15,000, but you had to spend $8,000 to hold the race. So can I just say we're bringing in $7,000 rather than writing? I could have written $15,000 minus $8,000 if it bothers you, but anywho, I'm going to type this on my calculator, and I already did this, and I get $2,500. So this is expected value, and it's not going to work for like 1 year. If you are trying to convince somebody to have this race, and you say like, we're going to make $2,500 no matter what, that is not true. What it's saying is, over the long run, if you're to have this race year after year after year, yeah, once in a while there might be a hurricane, but because of all the profit that you brought in from the other years, it's going to kind of average out to having a value to this company or whatever resort as $2,500. So there's your justification, I guess, if you want to think of it that way. This is a great problem, though, because this is what actually happens in life. So an insurance company insures a painting worth $20,000, meaning if it's stolen, they'll say it's worth $20,000, and to their customer they will hand them $20,000 check. But the customer has to pay $300 per year for their premium for their insurance. So they've done the math and they've calculated that the probability that it's going to get stolen is 0.002. Is that what it says? All right, good. So pretty low probability, but with that probability, what would be the monetary dollar that you have to think about? So if the painting is stolen, they're going to have to pay $20,000. But remember, your customer paid you $300, so technically speaking, you're paying the customer $19,700, right? Because you got to take away the premium that they already paid. Now, on the flip side of that, the complement of 0.002 would be 0.998. So that's the probability that the painting is not stolen. So the insurance company that year just made $300, right? So if I do the math here and I type this all into my calculator, I get positive, $260. So according to the insurance company, they're going to make a profit of $260 off of these anti-theft insurance policies. So that's how insurance companies make their money. Like, yes, there is a chance that, this painting might be stolen, but if you have hundreds of customers, all of their paintings are not going to be stolen, guys. Like, it's not going to happen. So this is how they make their money. The law of averages works out. I mean, unless something crazy happens, like a natural disaster or something. I don't know. All right. So there are more expected value questions. I'm going to actually go find them. I think it's on worksheet 14. I'm going to pause the video, find the right file. I'll be back in a split second. Okay. So this is a bit of a lie. It's not worksheet 16A anymore. I think this is on your worksheet 15A. And I'll go ahead and do 3 and 4, and I think that'll be enough expected value for us to kind of get going on these. These can be a little confusing, so I get it. All right, a landscaper mows 25 lawns per day on sunny days and 15 lawns per day on cloudy days. So if the weather is sunny 65% of the time, and it's cloudy 35% of the time, how many lawns can this person expect to mow? So it's not a monetary expected value, it's how many can they expect to work. So there is a 65% chance that it will be sunny, meaning they will mow 25 lawns. But the other opportunity or outcome, if you want to say it that way, is that there's a 35% chance that it's cloudy, and they expect to only get 15 lawns on a cloudy day. So type in that in my calculator. I don't know, I think I got that one done already. Comes out to 21.5 lawns, which is a stupid answer, right? But it's not saying he will literally mow 21.5 lawns. This is just how the math is working out. So if he's trying to, let's say, budget for the next week, and he's kind of looking at the forecast, and he's saying, okay, I'm thinking next week I'm going to mow about 21, 22 lawns. Like, that'll give him a good estimate. This next question, a little more confusing. Raffle tickets, right? So we have $150 tickets that are sold. So they're sold for $20 per ticket. The 4 winning prizes are $300, $150, and then there's 2 $50 prizes. So watch out for that one. And I want to know the expected value of just 1 ticket. So let's pretend I just bought 1 ticket. I want to know how much this ticket is worth. And basically, like, is it worth me buying? So I don't know who does this math for a raffle ticket. I think you just, whatever, buy a raffle ticket. But this is good stuff to know, especially for those of you who, as you go into adulthood, look into gambling, which we don't do now because we're too young. But some games are just not worth playing. You're expected to lose money, and you just shouldn't play them. Anywho, raffle tickets, kind of like gambling, a little less aggressive. All right, 150 tickets are sold, right? So you have a 1 out of 150 chance of winning $300, right? But you didn't actually win $300, didn't you? Pay for a $20 ticket. So it's really, you're only winning $280. But whatever, we'll get back to that in a second. All right. And then you have a 1 in 150 chance of winning the $150 prize. But again, you didn't actually win 150. You had to pay a ticket, so it's really won 130. And then someone be careful, there's 2, right? So you have 2 out of 150 chance of winning $50 prize. But again, you didn't really win 50, 130. And then there is a much larger probability, right? 146 out of 150 that you're just going to flat out lose. So in that case, you had to pay for the ticket and you won no money, so you just lost 20 bucks. So putting all of this into my calculator, and you can simplify it as much as you want, or not, your calculator does not care. You end up with negative 1633. So your raffle ticket is pretty much guaranteed to lose. You're going to lose. So then someone would say, oh, well, I'll just buy more. So, okay. I mean, there is a certain point where if you buy so many raffle tickets, like you've increased your chances of winning. Is it worth it? Sounds to me like probably no in this case. The payout prizes aren't really that significant. So just off the top of my head, I'm thinking this isn't a great raffle to enter. Well, hopefully it's for charity, right? All right, we're going to stop our lesson there on expected value. I am positive you guys will want to look at some more of these during class, and that's okay, but this gives you a good idea of how to get going.